Hello! In the previous video, we have learned how to make a single prediction using a single input. We have accomplished that by multiplying our input by one weight, and that generated the prediction for the tiniest, the simplest neural network in the world. So we have been trying to predict whether you will want to see a movie based on its IMDb rating. But as you can probably guess, surely this isn't the only factor that you would like to take into account. What if you would like to get more information and use it to make better predictions? You can't possibly make a good prediction based on just the IMDb rating. So how do we do this? In this video you will learn how to combine multiple inputs at the same time to make more accurate predictions. So here we want to add more than one input. That way we will be able to also pass the information into the neural network, such as perhaps Rotten Tomatoes rating or maybe a number of positive reviews that a movie has received. So as you can see, the neural network will look like this. Each of its elements looks a lot like what we saw in the previous video. You still take input and multiply it by a weight to get the output. But in order to combine them all, we will need to add them together to get the final prediction. So let's explore how we will combine them. As you can see, because our goal is to multiply each input by its respective weight and then add up together all the predictions, we will need to use something called weighted sum. This is exactly what it does. Output equals first input multiplied by its weight, second input multiplied by its weight, and third input multiplied by its weight. Then we will add them together, and basically this is exactly what it does, exactly what we need. That way we will combine more information, and we will be able to make predictions based on different data points. Each of the weights will multiply a data point in such a way that it will proportionally to how it impacts the output. If some input, if a large change in one input makes only tiny difference in the output, then the weight will be small. If some input might be small but very significant to our prediction, the weight might be larger. Excellent. So the next thing we need to figure out is how we are going to represent this in code. Well, it looks a little bit scary maybe, but don't worry, it will be very easy to understand as I'll take you through it. So think about it like this. First of all, how we will represent inputs in our code? Well, they will be represented as a list of numbers. So we will have a list that includes IMDb rating, Rotten Tomatoes rating, and the number of positive reviews. Very simple. In math terms, a list is also called vector. Basically, what we call lists in Python, in math we call vectors. And what about our weights? Well, weights will also be represented as a list. So here we have a vector of inputs and a vector of weights, and we will need to find some efficient and simple way to calculate their weighted sum. It turns out that there's a math operation that does exactly what we need. It just calculates the weighted sum, and it is called a dot product. As you can see, the dot product formula is pretty much identical to what we saw on the previous slide. If output is adding up together inputs multiplied by its weight, by their respective weights, here a dot product we will also multiply respective elements of two vectors and add them all up together. So here we have a vector A, 1, 2, and 3 are its elements, and vector B with elements 2, 4, and 6. So vector A would be equivalent to our inputs, and vector B would be equivalent to our weights. And if we will multiply each one of them together to calculate the prediction that each of these separate little units make, we can do it very easily like so, and then we will add them all up together to calculate our dot product. So this is basically a math operation that happens to do exactly what we need. So excellent, I hope you understand this, and to understand it even better, let's jump over to code and write a function that does exactly that. So here we are in my favorite Jupyter notebook, and we are ready to try to write a function that is going to perform a weighted sum. First we will learn how to do it manually, and then I will show you a trick that makes it even easier. So let's write a function that is called the weighted sum, and it will create a weighted sum of two vectors A and B. So how would we do that? Well, we would go through each of the elements of the vector and add it to the respective element of the second vector. Here we will assume that vectors have identical length, so they have the same number of elements, otherwise it wouldn't work at all. So first let's write output equals 1, equals 0. This is the output that we will want. This is our prediction. This variable will contain the sum of all the respective multiplications. So for I in range then A. So basically here we take the length of vector A, we loop through each of the indices in this vector, and because vector A and B are identical, it will allow us to also loop through each of the element of the vector B. And all we need to do is to sum them all up. A, for example, first element of vector A will be multiplied by the first element of vector B. Second will be multiplied by second, and etc. And all we need to do is to add this to output. I hope you can understand this. Each of the vectors is multiplied element-wise by another one, and each of the predictions is added up to the output. And finally we return the output. Very simple. So this will give you an intuition of what we want to accomplish. Just like here we multiplied each of the elements and then added them up, here we multiply each of the elements and then we add them all up to the output. Excellent. So let's try it out and see how it works. We will have our first vector, our second vector, and finally we will calculate the weight sum. Ta-da! Everything worked. It multiplied 1 by 2, then 2 by 4, then 3 by 6, and added up the results. Great. I hope it's easy enough to follow. So now onto the trick that makes it even easier. NumPy is a library that allows you to do very fast and very efficient numerical computation and operations on matrices and vectors very simply. So it will allow us to create a dot product. So we will import NumPy as NP. And as I have mentioned, weighted sum is identical to the math operation called the dot product, and NumPy happens to have a function that just performs this operation. It's called dot np dot a and b. Ta-da! We have identical result here because it does exactly what we want, but probably more efficiently or more intelligently. But this is essentially all we need to do. So this simple operation is all we need to do to make our prediction with multiple inputs. So let's define our neural network to see how it's going to look in practice. As always, we will create an n function. It will accept inputs vector and weights vector. We will want to calculate weighted sum of all inputs. And to calculate our prediction, we will simply do np dot inputs and weights. And we will return our prediction. Very simple and beautiful. Next up, we want to define our data. In the previous video we had only one data point, but now we will need a list of all inputs. So first we will define our features. The so-called features are different types of information about our data points. In this case we will have IMDb rating, Rotten Tomatoes rating, and our number of positive reviews. Notice that I have put them into lists, but not into integers. This is going to come into play later because with machine learning we need to process a lot of data points. For example, if you would like to realistically train a neural network, we would need to go through maybe 100 or 1000 of movies to look at their predictions and see how well our network matches them. We will explore all of this in the future videos, but for now we will have a list containing only one input. But conceivably we could have thousands of those for each data point. That's why I'm going to put them in list so that you would get used to it right away. So the next step we need to do is to combine these inputs into the array of inputs our neural network will actually be able to use. So imagine you want to go through 100 of movies and calculate predictions for each of them. What we would do is we would take the first prediction from the first from the first feature, from the IMDb rating, we would take the first Rotten Tomatoes rating, we would take first number of positive reviews, then we would move on to the next example, and then we would take the second number here, the second number here, etc. I hope you understand this. So to take our inputs, we will simply take the first values from each of the lists. IMDb rating, Rotten Tomatoes rating, and number of positive reviews. So we will take first elements from each of these lists to create our first list of inputs. It will look like this. Very simple. Again, it might be easier, you might think that it might be easier to just create a variable that looks like this, but I wanted to take you through all of this because in the future we will use many data points, and it's best if you get used to it right away. Excellent, so this is our data, and all that's left for us to do is to use our neural network in order to be able to make predictions based on this data. Oh, sorry, one last thing, of course, one last thing we needed to do is to define our weights. For now, don't hang up on where these weights come from. Assume that they are initialized randomly, and in the future we will learn how to train neural network to adjust the weights properly to make them have correct values that make good predictions. For now, I've just made them up. That's it. Okay, so our neural network. All we need to do here is to use it to create prediction. Prediction equals ANN inputs multiplied by weights. Not multiply, but we just pass them, and it does its neural network magic to create our prediction result, and we will print it out. Print prediction. Ta-da! So here in this case we would assume that this outputs likelihood of how likely we are to watch the movie, and here it would be like 92%. So that's it. This is how you create neural network with multiple inputs. In the future videos we will add more complexity to this neural network, because as you have probably heard that neural networks can have multiple inputs, multiple outputs, multiple layers, and we will go through all of this to understand it better, step by step. But it's important to keep in mind that fundamentally it is simple. The fundamental principle here is exactly like the one we had in the previous video, except that we have multiple inputs, so we need to sum their respective predictions. Imagine doing what we did in the previous video 3 times and then adding it all up, and that's it. So I hope this video was useful to you, and I'll see you in my future tutorials.